Hello everybody. So let us continue with term 3 work. So what we continue with, this is lesson 4 electric circuits here. So this question comes from Free State. So this is September 2025. And then, so let us read the question together. They say, in the circuit diagram below, the battery has an EMF of 10 volts and an unknown internal resistance R. Voltmeter V1 is connected across the open switch, and V2 is connected across the battery. Then I say the resistance of the connecting wires and the ammeter can be ignored, and then switch S is open. So switch S is open originally. Then, okay. 8.1, they say state Ohm's law in one. Okay, 8.1. What does Ohm's law say? So it says the potential difference across a conductor is directly proportional to the current in that conductor at a constant temperature. So the temperature has to be constant here. Picture. And then 8.2. There is 8.2.1. And there is also 8.2.2. So what is happening here? Now, this must determine the reading on voltmeter V1. Okay? Voltmeter V1 here is connected across the open switch. So there's an open switch here. Okay? Meaning what? There is no current that moves here. So there's no current passing here. So what does that mean? It means that the reading there is for 8.2.1 is going to be 0 volts. Okay, and then let's go to the reading on V2. V2 is connected across the power source. So it's connected across the battery in this case. So then what happens? If there is no current moving, then it means that the voltmeter across the battery will read the EMF. So then it means our answer here would be 10 volts. Okay. Okay. Now they go on to say switch S is now closed. The reading on V2 drops by 2.5 volts. And then they say calculate the reading on V2. Okay. So if it drops by that, if it drops by 2.5, meaning it goes from 10, and then it drops by 2.5. So we're going to say 10 minus 2.5, then we get 7.5 volts. So that's the reading on V2. And then for number 2, what happens? Reading on the ammeter. Reading on the ammeter. So the way the ammeter is connected here, the ammeter would do what? It would read the total current, isn't it? Yes. The ammeter here would read the total current. Okay. So what do we have here? We don't have the internal resistance, and we also don't have the total voltage of the circuit. The total resistance, I meant to say. The total external resistance, which consists of 1, and we have 6 and 3 here, connected in parallel to each other. Okay, so if we have a parallel connection here, and then the parallel connection is connected in series with the 1. So we can start by finding the resistance. So it's going to be 1 over Rp would be equal to 1 over R1 plus 1 over R2, which is going to be equal to 1 over 3 plus 1 over 6, which is going to be equal to, if we use a calculator here, it gives us 1 over 2. So this means, so this is 1 over R. So this means, therefore, Rp would be equal to 2 ohms, which means, therefore, R external would be equal to 2 plus 1, which is equal to 3 ohms. Okay. Now, from there, we can then find, because we have the external voltage, which is 7.5. Okay, so we then can say V external equals to I multiplied by R external. So the external resistance here. Then we then can say 7.5 equals to I multiplied by 3. And then we can then divide by 3 here. So it's going to be 7.5 over 3, which is going to be equal to 2.5 amperes. So that is the reading on the amp. Okay, so this was 6 marks. Okay, so you get 3 marks for the first step, and then you get the other 3 marks for using the equation here for V external, which is Ohm's law. So, and then, okay, let's go to 8.3.3. Now, internal resistance of the battery. Okay, if we are looking for the internal resistance, what are we going to do here? For 8.3.3, we can use the EMF. Okay, it's going to be I, and then R plus R, the equation for EMF. And then we have 10 equals to 2.5, and then 3 plus R. And then we can divide by 2.5. Take the 2.5, we divide here. So 10 over 2.5 equals to 3 plus R. So it means therefore 4 equals to 3 plus R. And then means that R equals to, means therefore R equals to 4 minus 3, which is 1 ohm. Yes. So that 3 becomes negative that side on the other side of the equation. So, okay, now 8.4. 8.4, they're asking, how will the magnitude of the current passing through the 6 ohm resistor compare to that of 3 ohms? So we use the resistance here to answer the question. So 6 ohms is 2 times bigger than 3 ohms. So it means that current passing in 6 ohm resistor will be half of the current passing through passing in the 3 ohm resistor. So it will be half. This is how it will compare. Okay. So this is it for this question. Okay. Leave your questions in the comment section. Okay. Let me hear what part gave you problems here. Okay. This was question 8. and then it had 4 questions, and those are the answers. So yes, leave your questions in the comments, please, and let us chat. I'll see you on the next one. Take care.